Okay, let's start then. Yeah, welcome to our noon session about reactive programming and RXJava on Android. So I can start with a small introduction about reactive programming. So actually, this slide is coming, I think, from the Reactive Manifest. What you actually want to build are systems or applications that are responsive and are actually seems always responsive to the user. So there are some characteristics you need. So those systems need to be scalable. So the more users you get, the system has to stay responsive. So the systems also need to be resilient. That means it has to recover itself by failures. If you have failures, it will try to recover itself for failures. And those systems are actually then event-driven also. So they spit a lot of events and they react on events. So all those characteristics together makes actually that you can have a reactive system. So how it applies on Android then? Go. Oh, sorry. Next slide. Okay. So for Android, responsive. Android is multi-threaded by nature, so you have a main thread, you have background threads. You may not block the main thread. If you do a lot of stuff on the main thread, the UI will hang, so your animation will stutter, or even worse, Android will just kill your application because you're a bad behaving application. So it's by nature multi-threaded. Resilient, actually, you don't want to hard crash your app. So those apps that you start up and something is not available and your app crashes by it, it looks really buggy. So actually, you want to recover from failures, like with network connections that get lost, sensors that get disconnected, or locations, for example. You don't want locations. So your app actually has to react on all these events and all these failures. So your app can fail for multiple reasons. And your app should still work all the time. So it should stay responsive to the user and give feedback to the user, like what's doing it, what's happening, and so on. Then, of course, event-driven. On mobile phones, it's also by nature event-driven. You have all the sensors that's spitting out events. Very often they work with system callbacks in the API, so you give it like a method or closure, and it gets called on an event. So actually, on a mobile phone, it's very event-driven. Think about the location manager, so the location client that connects to the GPS for receiving locations. You always get events every time location changes. Think about other sensors that also send events. So think of connection that gets established or connection that gets lost. They are just events happening on a mobile device. And then we have scalable, actually, maybe a little less for a mobile application, but scalable also means like it should not block. So the more the user starts using the app, it never should block. The more events you receive, you should try to handle all those events. The user should never wait for its application. It needs to actually be able to responds very fast. If you start your application, it should be there almost immediately there and doing all the loading in the background, processing in the background. So your system should really stay responsive. So there are a number of libraries for it. In the Java world, you have like Akka, those kinds of actor models. For Android, we start using RXJava. You have also a library with some extensions for Android, so you have RXJava Android. And the idea of RxJava is that you see the world as data streams. So everything are streams, and you're gonna connect and combine those streams, and you're gonna actually hook up with subscribers and observers on those streams, and actually gonna react when data is passed in those streams. So let me give you a quick overview of the core element of RxJava, and that's observable. I put now together next to each other what's the difference between an iterable and observable. Because of course a stream, you can see it also as an iterable, but actually an iterable is a pull model. So it works very sequential. You pull some data, next you receive that object and you're going to do something with it. An observable is actually like a callback, it's like a push model. So you define your behavior, what you're going to do when when the observable will be called by the stream itself. So it's a stream that calls your, when it emits a value, it will actually call your observable on next method instead of you calling on the stream the next method. So actually it's the opposite around. So there it will be pushed. So you're actually waiting for events to happen, and you don't block any threads or any resources. That's also main difference between them. So in iterable, you can ask like a next, and while the value is not available, actually you can block here the thread until the value comes available, and then you do something with the value. With observable, you don't block threads. For errors, the iterable just throws an exception, and then you have to do the classic Java exception handling. Observable has notion also from on error, and actually you can decide there what you want to do with the error. So you actually can subscribe to a stream, and if some error happens on the stream, you will be notified like that the stream is stopped, and it's stopped with an error, and it passes you the throwable, and then you decide what you want to do on that specific place. The same with completion. So when the event stream dries up, there are no items that it needs. So it doesn't have any items to emit anymore. It actually will call all the listeners, all the subscribers that it has completed with uncompleted method. So you get a callback that is uncompleted, and then you can do your stuff that you need to do after the stream is finished. With a normal iterable, that would mean like if the iterable returns, you do things. So how does it look? If you go to RXJava, the wiki, they have actually quite nice documentation. They make everything in like these kinds of diagrams. So actually what you see is like the arrow is like a stream of data, and on that stream of data, you have certain kind of events. So for example, the first item event, there is a star that's emitted out of the stream, and you're gonna actually do stuff on it. So you can do actions on it. In this case, this example is the flip method. So you're gonna manipulate the star, and you see that actually you get a new stream of data that is being manipulated by, in this case, the flip function. And you have a lot of operators like this. Let me otherwise show you the wiki to give an idea. So it's like, this is, for example, like for creating observables, you can have like a lot of methods here. That's like the just or the from, where you have already a predefined array that you can create observables. You can combine observables, for example, with merge or zip, combine latest. And actually, that would be like, for example, let me take an example with merge. For example, here you have two streams of data. For example, that could be like you're listening to changes to a stream of locations, like from the GPS, and you're listening to another stream of data that you have. And actually, you want to have both at the same time. So you could merge those data on one stream. They could actually all the events like together. Okay, I'm not sure if there are questions about this. So you have a lot of, you see here you have filtering, for example. So you can actually filter. You can, for example, take the last. You're just interested in the last element. So you have a stream of data. And for example, you just want the last when it's completed your stream. You can use the last function on your observable, and then actually you will just when the completed is done. It will emit only the last element. So you get actually applying, if you apply the last, you get, for example, in this case, a new stream with just one element. That's actually the last element from the previous stream. What it does is actually it allows us quite easy to have complex scenarios where we have actually like sensors that go down and sensors that come up and network that goes down and network that comes up. All these kind of events that makes actually quite complex to handle. Also on then Android, for example, the Google Play service that are not available or are available. You can start combining those. You avoid actually the complexity of all the scenarios. You can actually start putting everything in streams, and you just combine the streams, and when something comes through the streams emitted to it, you react on it. And I'm going to show you some code to it. Let me see. So let me select you. I think it's this one. It's okay. It's readable. Can you zoom in? Settings.
Yeah.
I'm trying to increase my font here.
In editor, reference editor, font. Yeah.
Sorry. Settings.
Yeah. Settings, editor.
Here's the fonts. Custom. Okay. Let's say this is okay. Better? Okay. So what you see actually is like it is actually a pojo that's bind to an activity. So it will, when an activity gets created, this is actually the Agile Tour app. So what the application does, I'm explaining that a little bit. It's like an application does is like when you're near Cegeka and you walk around, it's actually to visit our Agile software factory. It will start scanning for iBeacons if you're near the facility. If it finds a certain iBeacon, it will show you some information on a screen. So if you walk around in the building in Haasrode, it will start actually scanning for beacons. Of course, if you're not in the neighborhood, you don't want to start scanning and using the battery. So actually, it shouldn't do anything. How did we solve it with RXJava? Actually, made like a stream of locations, and this is what the location service does. The mass location gives you an observable black with location. It will emit only one value, namely the last location it knows, and then it stops. The stream stops. One value will be emitted. Then we can actually bind further on this stream. So we have a location. So that actually is, we want to filter it. We want to only keep the location if you're nearby Cegeka. Nearby Cegeka means that location here. So nearby Cegeka, this means this, that the distance to the meeting point, and the meeting point is a longitude and latitude from the reception here at Cegeka, if the distance is smaller than 2 kilometers. So if you get in an area of 2 kilometers, it starts actually scanning, and you start application, it starts, it allows the event to continue. Then actually we do a flat map. Flat map means that actually you have an observable which starts emitting new observables, and it will make a new stream of those observables. So what we do is when we pass the nearby Cegeka, so we have still a location, we're going to flat map that to a stream of beacon events. So actually then we're interested not anymore in location, we had location, it passed our filter, so we're close enough. Actually then we want to say like, okay, this event, this location now, I want to start actually listening to beacon events. And what we do is we have a beacon service that we actually start scanning to. It gives you back an observable from beacon events. That's what FlatMap does. So you can have multiple locations. It will actually start now broadcasting beacon events. A beacon event is something like you enter a region from the beacon, you exit the region on beacon. So beacon is something that sends out a small signal through Bluetooth. And if you enter a region and it detects the beacon, you will get an event. If you leave, if it detects it doesn't get that signal anymore, you get a new event that it says like you left the region from the beacon. So actually now we have a stream of beacon events, and we actually are just interested when we enter a region. So this is the next filter on the beacon event. We're going to filter here the enter region. So we're going to see to the event type from the beacon event. It has to be region enter, and then otherwise we just ignore it. We don't continue with it. Then we do another flat map. So flat map means make from one observable a new observable. So that event, that beacon event, we're gonna now flat map it to proximities. We are interested in how close are we to the beacon. So we have a beacon event which has a beacon, and the beacon object has a map. Let me show you that. So to proximities, the beacon event has an iBeacon, and actually that proximity is again an observable. So if I go to this code, it's compiled, sorry, it's from a library, but it gives you an observable from proximities. So it's not a proximity, it's not one value, it gives you like a stream of values. So actually the iBeacon, you can ask a proximity, instead of giving you a value like I'm so far from which is just like a snapshot in time, it gives you actually like an observable from proximities. So while you're moving around, it will just emit values there. So you get actually not one value, but you get like a stream from how far you're from the beacon. And what we do then is actually we just want to be, because a beacon can be like, I think, 20 or 50 meters. You want to be close to the beacon. So you just say like, you filter again with near enough to the iBeacon. So you're going to see if the proximity, in this case, is smaller than 8. It's just trial and error I did to see if it's close enough, if the beacon is found fast enough. If you're close enough to the spot you want to show, then actually you're going to do something with it. And what we're going to do then is map our proximity. So the proximity itself, we're going to map it to a page. So we have like a slider from our Agile tour, which has like 6 pages with all information on it. We're going to say like we are close to proximity. Which proximity? Okay, we passed the complete chain. So we know that you have to show now a page. And which page is it? So in this case, we're going to see it has a mapping from each page. It has a mapping, so you have a about page, a welcome page by Agile versus timeline. It has a mapping with a beacon, with a major number from a beacon. So there we map actually a beacon on a page, and then that's it.
Otherwise, can we show the application? Do you have your cell phone here?
Then I have to start emulators.
No, with your cell phone, I can put it in the camera here.
Let me see.
Or you can.
I will give you a point. Sorry.
Just to make it very concrete.
This is Agile. And it jumps into there.
Yeah.
So, yeah, if you otherwise go back with the back button, so what you see is like if you swipe, because we're now in the buildings of Cegeka, it's scanning for iBeacons. It will always jump to, I think the closest screen is here about the Agile values. At a certain moment when it detects again the beacon event, it will jump back to the.
Yeah, that's what I want to ask. Your proximity changes, like you're closer to the beacon, but it's still the same beacon. You will still do the page 4 thing.
Sorry? Yes. At the moment, yes. But you can, if you want, you can do more advanced stuff. You can also like start filtering. Like I already had this like a history, like that you say like I just want to move to the next page if I already visit. If I didn't visit yet that page, for example.
What does page 4 do actually?
It's a mapping. Actually, I've got an enumeration in the application for pages, which is like the identifier welcome page. And actually, that's the mapping. Like you have a beacon has a major ID. Every beacon is actually mapped to a page. So the major ID from an iBeacon corresponds to a certain page, and that page 4 actually gives you back the enum, the page, to know which fragment which screen he has to show. That's it. What's also important is like all this chain is passive. What you see in this model, I put it here as a field on the main model. It's an observable. It doesn't do anything. All this code that you see here, it just will do something if somebody subscribes on it. So actually, this code that I wrote here now is completely cold. So you have cold and hot. It's like when you write this here, it will not listen to locations. It will not listen to beacon events. It will not do anything. So it's not triggered. So it's actually just sitting there. And if you want to test this, I can show you after how it tests this. Actually, in a unit test, you can make it active there. So actually, it's all serial then. You just put it like a location service, some values in it, and then you can verify on the subscriber that you used if there are the values that were needed. To show you where when it starts emitting, it's actually let's see, it's a main fragment. Yes, we have a life cycle. So in Android, you have a life cycle when you come to the screen, when you go to the background, that kind of stuff. And in the life cycle for fragment, you have an onCreate view. Sorry, it's in onResume. So the view is created, and then actually you get the next step of the life cycle, and that's onResume. What we do in onResume, there actually we decide for because then that means like onResume means like your application is visible to the user. That's the moment actually that we want to start doing all that stuff. We want to connect to the GPS. We want to listen to iBeacons because that uses battery life. So we actually postpone the decision to connect as far as possible. So when the app comes up, we actually connect to our page object. So we had that page object which is called, didn't do anything, but we know that it emits pages. And what we do actually is we observe on the main thread. We say like, okay, we want to be notified on the main threads. So you have multiple threads. One is Android main thread. When you manipulate the UI of Android, you have to do it on the main thread. So you say like, okay, I'm going to subscribe to it, but I want to be notified on the main thread. And what I want to do is when I get an event out of it, I want to say to my view pager, that's a component that actually swipes through pages, I want to save the current item to the page number. And by subscribing now, actually the whole stream gets active. The whole stream actually starts connecting to the GPS, starts working together, starts filtering, starts connecting to iBeacons, starts filtering on proximities. So now it gets all active. When you move to the background, you want to stop, of course. You want to disconnect from the stream and say, like, release everything. And that is with this subscription. When you subscribe, you receive a subscription, and that you can hold. So you hold the subscription to the stream, and when you say on pause, you move to the background. Actually, I say then unsubscribe. And unsubscribe means that the stream gets called again. So all the elements in the stream will be notified that there are no subscribers anymore. And actually will disconnect from the GPS, will disconnect from whatever resource that's called. And so we have made a decorator around the GPS API from Android. It will see like there are no subscribers anymore. So the last subscriber unsubscribe, he will detect it. He will see like there's no subscribers anymore. Okay, I disconnect from the GPS. From the moment that there is somebody subscribing, he will connect with the GPS. So actually, instead of putting that code in your activity and fragments, you hide that as far as possible to the background, to the infrastructure layer. When to connect to GPS, and that's not responsibility from your application. We're just interested here in streams and data streams.
Is it okay if we check how are we with respect to a load of information?
Yes, sorry, because I'm now spitting out information.
So,
I can follow, even though I don't know Android.
but you know streams.
Yeah.
Okay. And in Romania?
What do you think?
It's interesting.
Can you follow actually?
Sorry?
Well, I'm not an Android developer, but I'm very interested in how exactly this framework works, because it's very interesting not to have blocking points. I think it looks a lot like Node.js. Can you hear me?
Yeah, I can hear you. I'm not so familiar with Node.js. I know it's single-threaded. So in a sense, like the advantage here is you don't have to worry about threads. You just define your streams. And in the parts of the streams, you can define on which thread it has to run. So by defining your stream, you can define like this part of the stream I want on the main thread because it has to be on the main thread. And that part of the stream has to be on an I/O thread because I have like network connection or connected to a sensor. And that another part of the stream I want to on the compute thread that actually is for computing. without too much fuss about it. You just declare your stream, and in the parts of the stream you can declare on which thread it needs to run. I know with Node.js it's more single-threaded. It's like one thread, and that does all the thing. So don't know if there's much similarity between the two.
RXJava is not Android specific, right? Like you can use it in. Okay.
It's for all platforms, and even JavaScript and all languages almost. So RX is like the reactive extensions. Where it comes from is from Eric Meyer, did it for C#. He moved to Netflix, which actually is Java, and they start implementing it for Java, for Scala, actually because it's Scala under the hood, so they use Scala. It's actually also for JavaScript. I think almost every language you can imagine, there is an RX extension for it now. So every problem, but it's a little mind shift how you think. You really start thinking in streams. Everything is a stream, and you react on streams. So it's not really like object-oriented programming where you make a big model. Your model actually, like how we build now in our Android applications, also have streams. So at a certain moment, you have to make a decision like if you're interested in returning a list where you just iterate over it, or you return a stream, an observable from an object, and actually let the subscriber subscribe to it or not. So it's a little bit more difficult if you just are used to pure object-oriented programming. It goes more like to functional programming.
The thing is, the library has so many methods, has so many useful things that actually you can insert some RxJava even if you don't have already observables or a stream of events. You can just create them out of a flat list, right? Like an array.
Yeah,
just
let me give you an example. For example, because I had some test here, the test model. So this is a test of my stream of that model that is here. What you see is that I use Mockito for that location service. So it's like, okay, see here, this is location service, and I say, okay, what last location is called, and then you can say I make an observable from, and this is an array from an object. This is actually like a location. So I actually set there an observable with one object in it. The same for the scan beacons. I return a new beacon friend region enter. The same for a proximity. I create an observable which is close to the beacon. I initialize my model, and then actually in my test I subscribe to it with an observer which is actually a mock. This observer. So what you see here, it's just a mock from Mockito, but it will be called. Come back here. So actually, I make now by subscribing in my test to. Okay, by subscribing with the observer to the page, the streamcat swarm will play all the events from, emit all the items from the streams that I put in the given, and actually I can start then verifying my mock, my observer, that it's never called on error, that it has been called with onNext and the timeline page. So I expected here that it's the timeline page should be visible. So I'm close to a beacon that is the timeline. And I verify also that it's uncompleted has been called. This is actually my test from all the stream. So and you have multiple. So for example, when you're not close enough to a beacon, so you scan for beacons, you give a beacon event, and the proximity is something far away. Then actually when you play this, and because the stream is not jumping from threads, it's all synchronously, it should never call on next, and it should have been called on complete.
Well, this method, if I can say something about this method, could you go a bit up to show the complete method? Normally, in a standard method, what we have in the when part is the actual call to the method we are testing. And if you see that the method we are testing here is the onCreate, so the model onCreate. But all the effects of the onCreate will be seen in the observer argument that we are giving to the subscriber. And that's why we can, in this case, verify things on the observer, like if a particular callback was called or not. Another alternative would have been to really create an observer and then inside of the callbacks do something else. But yeah, this way is already clean to test what we need to test. And another thing that, okay, some analogy that has helped me a lot to understand observables is that in the given part, they will then return. So all the observables there, you can really understand them, yeah, to some extent as collections. There I give in collection of one element. Yeah, that in the reactive world is called an observable. Okay, but it's just a collection. In this case, it's synchronous, so you know exactly what the collection the observable will contain. It's one element. The difference is that when the program is running, that collection is undetermined. So you don't know all the elements that will be there because they are produced as you generate events. So as you touch the screen or you receive things from the backend, you will generate events that will be added to this collection, which is actually observable. That's the main difference. And that's why the test looks kind of similar to our test. The only difference is that you cannot, you need to use this observer thing to verify the effect.
Yeah, the reason is that our method, like onCreate, doesn't do anything. It just puts the streams ready. The streams are called, so actually all the behavior is there. We define all the behavior in onCreate methods, but because nothing is interested in it, it didn't do anything. It's just gonna do something when somebody says like, "Hello, I'm interested. Give me items. Emit me items to the stream." And that's actually what the when does with the subscribe. So there you make it really the stream hot. Say like, okay, close my onCreate method. Like what you said, now start emitting me values. You can verify then the mock that you pass as an observer. Irina said something like you can make easy your own observables. I'm going to show you otherwise code because very often, like in Android, you have like APIs that are very like with callbacks and that kind of stuff, which are not really like observables, like how you decorate them and make an observable from it. Because you have something like the notion of a subject. A subject is actually an observable and is a subscriber at the same time. It's both. And you have otherwise code first to the screen share. This one. So let's go to subjects. Yeah, subject. So subjects are like observers and are subscribers at the same time. And you have different ones depending on what you need, what your needs are. You have different subjects. For example, you have the async subject, which means if you have objects and you subscribe to it, it waits until it's finished, and then it will emit the last value. So to a subject, you can actually say, you can call onNext, and by calling an onNext on a subject, it will notify the subscribers from the subject. So on a subject, you can subscribe yourself, say, I'm interested in this subject, and another part, you can actually use a subject to push values in. So you could call onNext to a subject, and then that one the subject will notify its subscribers. And if, depending on the subject, it has certain behavior. So with async, it will just emit to its subscriber the last value. You have a behavior subject. There you say, like, I make it with an initial value. And when a subscriber connects and not a new value was emitted, he will receive the default value. From the moment that another part of the application starts pushing data to that subject, so it calls onNext on the subject, like the red one, then to its subscribers, it will start emitting those values. And if you subscribe again with another subscriber, it will receive the last value that was emitted by that one. You have a publish, that's the typical queue thing. It's like a queue. So you subscribe, and whenever the next value is emitted, you will receive it. If there were previous lag, so for example, this one is a little bit later, it will not receive the red and the green one because that is past. So it's like a topic or a queue. You just post something, and everybody that's connected at that moment will receive the value. And replay is actually like, you can say like how much elements he has to remember. When you subscribe to it, he will replay those elements for the subscribers. So it has some nice characteristics. And let me show you otherwise in the code how we use it, for example, for the location client. So I'm gonna no. So yeah, I'm starting up a new Android Studio, so a little bit of patience.
I think when you get the hang of things, you can use the RXJava in more places if you start thinking like that, like your stream. Because there are many models in real life that you can use.
Something or
Sorry, Irina?
No, I would just emphasize. That's okay.
Okay. So let me take the location service here. So this is our implementation of the location service. It's a decorator around the APIs from Android. And actually, it's what we used in our other application when you want to get a connection. Let me see the methods. I'm looking for the. Okay, here it is. Get last location, for example. Sorry, screen is following. Okay, now this one is the one that emitted the last location. So it's observed from location. Now, how is it implemented? Because Android itself doesn't have observables, doesn't work like that. What it has is actually the location client of Android, this object. And actually, what we do is we have a replay subject. So that's here now. The subjects come handy. So what we're gonna do is actually the replace subject. We're gonna say that it has a size 1, so it will always have a value. Okay, initially it doesn't have any value. So if you subscribe to this subject, you will receive no answer. But when we start pushing locations to this subject, it will remember always the last location. It has one value, so if a subscriber arrives, it will receive the last location immediately that the subject has. So by doing this, we can say like, okay, get last location. Actually, we want a stream of all the locations, but we want the first one. So here you see again that you start with a complete stream, and then you move by applying a function. You can move to a new stream. So actually, the get location, this function, it's again an observable location, but that's an endless stream. It just keeps going without ever completed. By using the first, we actually make a stream of one object. If one object is emitted, this stream will be uncompleted. It will meet that value and then stops with it. So when you ask last location, we're just interested in one location, and that's it. So we can actually use that combination from the location stream with the first method to have the last location. What we actually do is, and that's this method here, put it in the middle. Here we start subscribing. So actually what we make is a new observable with create, and you give it a function. This is also subscribe function, and also subscribe function has a subscriber. So that's this one. Let me clap it open for you. Java is a little bit ugly. Java 8 is better. Wait, I will close it. So actually, what you do to the locations, that's a subject. We subscribe this subscriber to the subject. So this subject will be subscribed to the locations, which gives you back a subscription. Okay? You remember, so if you subscribe, you receive a subscription, and with that subscription, you can unsubscribe or not. So actually, that subscription, we pass it back to the subscriber. So we subscribe to the subject, and actually the subscription that we give it back to the subscriber. That's this add method. So this add method is add a subscription. So the subscriber will receive a subscription, but not from our code here, but from the subject itself. So the subject is the mediator between all the stuff. So we don't have to track our own how many subscribers are there. We use a subject for that. And then we say, like, by definition, you're going to go to the I/O thread because we want to use like to GPS. So we have to go off the main thread. This has to be this method here has to be executed on the I/O thread. And actually, by default, we say, like, if you chain a bit further, you will receive it on the computation thread. So not the thread that you call, because otherwise it would be the main thread very often. So we force here actually everybody that uses our service that if a value is emitted to them and they subscribe to it without specifying a thread, that they will receive it not on the main thread, but will receive it on the computation thread.
Could I come back to where location is defined? Locations?
That one is defined. It's coming.
It's the replay subject.
It's the replay subject.
Yeah.
So that's the locations. And now, actually, this class connects to the client, so it has knowledge of connecting and disconnecting. It has a complete life cycle when it's unconnected. The good thing is that the clients, the subscribers from our service, doesn't have to handle the complex life cycle when it gets a location client gets connected or disconnected. So this is the Android APIs. When we get connected, we can make a new, and that's Android APIs. We can ask it, like, give me request location updates. You have in Android, you have to give it always a callback. So we can give ourselves as callback, so it will call us again when locations are changed. And these are this callback. So when the location is changed from the Android, we push it to the subject. So actually, we don't. This means that all the subscribers that are subscribed will receive that location. So you hide the complex setup and lifecycle from the location client from Android behind a stream of observables. The same on disconnected, on connection failed, for example. Here you handle the error, so you start trying to resolve you have the lifecycle that you can try to resolve. For example, your GPS is off. Then Google Play Service will say, like, yeah, it failed, you have a connection result, but it's resolvable, it has a resolution, namely switch on your GPS, so you can try to resolve it. If that fails, you actually say to the location, sorry, to the subscribers, there was an on error, it didn't work out. The same, if it's not resolvable, you just say, like, on error. And actually, every subscriber that is subscribed knows something went wrong. He doesn't receive any locations. So we handle all the complex lifecycle here behind the scenes. Another example of this is actually like rotation sensor. This is actually when you turn your device. We calculate the degrees it's turned around the X, Y, Z axis. And actually, we make 3 streams. You have to connect X, connect Y, connect Z. So depending on what you're interested, on which axis, you can actually connect to the stream and start listening. And it's actually, again, the same, but this time it's a published subject. So from the moment that you subscribe, it's possible you don't receive any item. The first time that there is like a change from the sensor, you will receive the item. And so it's, again, you have to observable, okay, when you say connect X, we pass it to subject. So actually, you're going to subscribe to the subject and give the subscription back to the subscriber and start listening here. We actually start, not sure if this way to do is like, we keep track of the number of subscribers. So we have a start listening. Actually, we want to switch on and off the thing. So actually, we discuss increment and get, and actually start listening to it. So when we have the first one, so if there is at least one subscriber, that's when we say to the connection to the sensor manager, yes, I want to receive events from the sensor. Otherwise, I don't care about it. So the same, stop listening, it will decrement. So actually, what you will see here is we have a method that we can add to the subscriber. So you can add other methods that actually you can say, like, okay, that has to be called when you say unsubscribe. So when a subscriber is calling unsubscribe on the subscription, this method will be called. And actually then we decrement number of subscribers, and we go check if we are 0, there are no subscribers anymore, then actually we can say to the sensor manager, there is really nobody interested anymore in events, stop using battery, stop with stop with listen.
And what does this do? Like all this code for the rotation stuff. What do you use it for?
We use it for in our application, for example, in the Agile tour for moving the image. You have a background image, and I can show you.
I can show it here.
I think I have to unlock it.
Just rotates the image along with how
Yeah.
you look
You can
at
do
it or
whatever
something.
you want. It just emits degrees. So
I have a question.
so that's what it does.
Yeah.
So it listens to degrees around the y-axis, and if you move your phone,
I'm not here, for instance.
and actually I can show you that code also. That's in there.
But what is important here is that there is a pattern emerging in this case, because the thing is, the sensor that will say, okay, X has changed or Y has changed and Z has changed. The way you normally handle this is by means of callbacks. And if you want to compose what happened in X, what happened in Y, what happened in Z, well, in this case might be simple, but and what happened in something else, in some other sensor, you need to start combining the results of callbacks in kind of global state, right? But the pattern that is emerging here is that basically we say you take the event source and you create an observable or a subject out of it, okay? And from then on, what you will start composing is streams, and I guess this is what the part will show now or something.
Yeah. So you ask what we do with it. This is the code that really use it. So actually, what we say here is like rotation sensor we connect to X, rotation sensor we connect to Y, rotation sensor connect to Z. And the reason why is originally we were just interested in Y rotation. Seems out. Okay, we found out that tablets has the opposite axis. So for that we had to take into account certain stuff. But never mind. For that we actually are using all values. So previously we just used, that's what the reason why it was split. It's like you just used the y-axis, but apparently in tablet it turns out it's the opposite around. So because their landscape is in normal mode. So the y-axis is the axis that goes from down to up in normal mode, and tablets is landscape mode, and phones are portrait mode. That's details. Actually, what we do, we have 3 streams here now: X, Y, Z. We do a zip on it. And zip means combine those streams together. That it means always, if there's a new value on one of the streams, it will make one value. This is a method. And you will create a new value out of that. So in this case, we get like X, Y, Z. Yes, we get a function.
In one function, you see?
Yeah, and actually we emit a new one. So actually what we emit is like, if it's landscapes mode with the Z rotation, we can see the Z rotation. Then I'm interested in X rotation. Otherwise, I'm interested in the Y rotation. And then we actually observe again on the main thread. On the main thread. And we subscribe with an action. So this is a subscriber. So if you're not interested in complete, on error, you have also action, just do something. This is a subscription that actually then say rotate the image. And this is the rotation in degrees that we got. And then we just manipulate UI stuff, like that kind of stuff with it. But the same principle again with the subscription. So if we subscribe here, we get a subscription, one subscription, all this chain. And on resume, we subscribe to it, and the stream gets hot. And on pause, if you go to the background, so your app is not visible anymore, so it doesn't matter if you don't want to use battery, so you disconnect, you unsubscribe from the stream. So you have multiple streams combined here, and actually, it's quite easy to just subscribe to it and unsubscribe to it. And you just combine streams and filter and do all the stuff you need to it. And you can do it on the background thread, foreground thread, computation thread, whatever you thread it like. Yeah.
And are there any like special garbage collection pitfalls or something like that?
Like
I don't know, if you unsubscribe from the stream, but then earlier you said our object is gold then, basically, yeah, right?
Yes, the stream is actually if you would see the debugger, you would see actually a chain of functions. It's like functional programming. So you make your chain, and it's actually a chain of expressions chained together.
That's in a gold state.
That's in a gold state, and actually when you subscribe, you have one object that's subscribed that goes through the chain until it gets actually to the sources that emitting. So those sources get the event like there is a subscriber for me, and all the sources there start emitting, and then all the items flow through the chain you made up to your subscriber.
But I think that, I would like to highlight another pattern here that is pretty cool, and it's the fact that, okay, one of the most difficult things in Android is reasoning about the life cycle of fragments or of activities and like that. And how you compose this with information coming from sensors is not always straightforward, because you need to start listening, and suppose you need to stop listening, and then it's not easy. Whereas here, as Bart said, we have the concept of subscription, that we can subscribe on resume and unsubscribe on the unpause. And basically, we have applied this pattern in all the cases. And that's it. So there is no extra work you need to do if you want to stop reasoning about sensor information.
In typical Android code, you see in your fragment activities a lot of code that actually will start subscribe on the background thread, so you connect to it. But it's possible that your fragment's getting destroyed while you're still receiving events from the sensor in the back. By using the subscription, and in on resume and on pause we unsubscribe group, we actually stop immediately from events. We say like, we unsubscribe, we're not interested more. Is some event coming? Just throw it to the garbage. I don't want it anymore.
Because normally an event will change something in the GUI, but if the GUI is not anymore there, we have a problem, then exceptions and so on.
Yeah.
So here is a pretty clean way to keep that consistency. And the other thing, but this another emerging pattern is if you see in the onResume method, there is all this chain of calls, and there is this observe on main thread. So that line is important. Why? Because from then on, the chain will be executed on the main thread. So this means that in RXJava you have a way to control from when you start using the main thread. And in Android, it's important that we use as least as possible that thread. And in RxJava, you have a way to say that. So all the computations that happened before will be executed in a different thread.
If you remember, service actually, before returning observable, set there that the observe all was on the computational thread. So before I give back I force all my service that they use my observable the background thread. So it's a nice way to actually identify which part has to run which thread.
Indeed.
So you have multiple observe alls in your chain of your flow actually. Every time you will swap to another thread. So it's easy actually if you find your flow, jump from one thread to the other thread.
You have complete control on that.
And in Android it's important because you have the main thread and you have background. So
cool.
Yeah, for an enterprise application it's sometimes as important. In a sense you have probably a thread pool and all threads are equal. But in like if you use UIs, like web clients and mobile applications, you very often have a main thread is used for drawing an animation. That one you want to occupy, you don't want to block it.
Start wrapping up.
Yes. Somebody wants conclusions or
questions or comments or it would be nice to get the opinion so that we can improve for next version.
For me, the most confusing part is about creating an observable. That's not really intuitive what you have to do there.
Yeah.
Explain a little bit in more detail or something.
I think to create observable is actually quite easy. It's just observable create, and you give it a function, and the function will have a subscriber to you. So every time a subscriber is called, it will call that function. And then if you want to decorate it, if in that function you know how to emit values immediately, you can just use that subscriber and just start emitting values. that's okay. So you just have that callback function with the subscriber, and you can just call it. The reason why we use the subject in the other ones is that we have a lifecycle of Android APIs with callbacks. So we're not linear calling. So like, for example, for the GPS locations, when the subscribers subscribe, we don't have locations there. So we just have a subscriber, and we still need to connect to the API from Android with a callback, and then receive locations. And that's the reason why there we choose for a subject like actually like a queue or a topic that on one side our service is posting locations on that queue. On the other hand, if a subscriber comes, it subscribes to that queue.
Yeah.
Is it subject?
All you have to do is push the events to that subscriber, right?
Sorry. Could you repeat, Tom, please?
So
My
the
question was, is a subject then kind of an adapter for a data source that doesn't fit into RXJava?
For asynchronous data source.
Yeah.
Because if it's synchronous, it's like a database. You can still query a database synchronously, get the results back, loop over the cursor, and every item you find in your result set immediately to the subscriber.
Yeah.
And you don't need a subject. But if you have a data source that's asynchronously by nature, you have to call it, but you don't get results back. Yeah, you want to call the subscriber when you get called by the asynchronously database or data source. You want to pass those values back to the subscriber. Then you can use a subject to do that. And depending on what you want, you have different kinds of subjects. So you have replay subject, which I used on certain places just because it remembers the last value, like the last location. But on something like with the sensor there for the rotation, I was not interested in the last location. I used just, I think, the topic or just the publish one. So there you have a publish subscribe pattern.
There was somebody in Romania who wants to say something.
no.
I want to say something. So I think there is still an issue with blocking operations. So let's say I have some long blocking operation that I want to put in the I/O thread. So I wrap my functionality in a subscriber, and let's say this takes, like, the actual operation takes a lot of time. Basically, it will freeze the whole I/O thread, right? So other
Not necessarily. The I/O thread can be a thread pool. You can have multiple threads. I don't think in the I/O thread you have just one thread.
Okay.
And you can always do your thing on the I/O thread, and you have a computation set, go to the computational thread. So you do network traffic on the I/O thread, and whatever you read, pass immediately to the computation thread for their computing. So actually, under the hood, there are just thread pools. Only for the main thread, there's just one thread. That's the main thread. So that just there you have one thread. But for the other ones, it's implementation dependent of RXJava.
Okay.
Actually, the big promise of RxJava is to decouple the way of working with threads from the current implementation. So behind the scenes, you can use whatever. You can use one thread or many threads or
actually,
factors or.
What they use is not threads. They use the notion of schedulers. If you really want, you can make your own scheduler. It's just like an API, like an interface, and you can use whatever thread pool under it that you like. You can give it a complete thread pool with a lot of threads, or you can limit the number of threads. That you can decide even yourself. So you can make your own scheduler if you don't like the ones that are provided by RxJava, and it's in the observe on, you just give your scheduler.
Okay.
I think we can wrap up.
Yeah. Thank you.
Thank
Thank
you.
you. Bye bye.
Bye.
Ciao. Bye.